There is an African bean that contains every essential amino acid humans need to survive. It fixes nitrogen. It thrives in drought. It produces complete protein without fertilizer, without pesticides, without purchased seeds. For over 1,000 years, it sustained West African civilizations. Colonial agricultural departments documented all of this, studied it in research stations, and published reports on its advantages. Then they promoted peanuts and cotton for European export instead. They classified it as a minor subsistence crop. They built entire agricultural systems around crops that required inputs this bean did not need. They created protein deficiency in regions where complete protein grew wild. Today, development agencies still fund soybean programs that require fertilizer packages while calling this African legume neglected and underutilized. This plant requires nothing industrial agriculture sells, and that is precisely why they had to keep it invisible. This is the story of Bambara groundnut. In the highlands of West Africa, farmers cultivated Bambara groundnut for over 1,000 years before colonial officers arrived with clipboards. The archaeological timeline is difficult to establish with precision. Pottery residue speaks. Oral histories speak. The crop's very name speaks. It is named after the Bambara people of Mali. That naming pattern signals deep cultural integration, not marginal adoption. The geographic spread confirms its importance. In Burkina Faso, Mali, Niger, northern Ghana, northern Nigeria, and parts of Zimbabwe, each region developed its own name, including Bambara, Jugumawe, Okpa, and Kwaruru. Linguistic diversity proves that cultivation was widespread across centuries. Traditional agriculture integrated Bambara into polycultures refined over generations. Women farmers grew it intercropped with millet and sorghum. The beans fixed nitrogen for companion grains, and the low vines shaded soil, conserving moisture through long, dry seasons. Cultural significance extended beyond calories. Bambara appeared in ceremonial foods, and communities used it for weaning children. Mothers recognized its complete protein value intuitively, without laboratories. Storage capacity made Bambara a form of survival technology. Dried seeds last 2 to 3 years without refrigeration or chemicals. Harvest happens in November. Store through the harmattan winds and plant when the rains return. That meant food security without cold chains, without preservation infrastructure, and without dependence. They understood what would later be confirmed in colonial research stations, and then that knowledge was systematically ignored. Analysis of Bambara groundnut reveals nutritional properties impossible to explain away through ignorance. Protein content ranges from 16 to 25%. That matches soybeans. But unlike soybeans, and unlike nearly all legumes, Bambara contains all 9 essential amino acids: methionine, lysine, tryptophan, the complete set. Compare this to peanuts. Colonial agriculture promoted peanuts across these exact regions. Peanuts contain 25 to 30% protein. Higher numbers, but an incomplete profile that lacks sufficient lysine. Peanuts need 500 to 1,000 millimeters of rainfall each year. Bambara survives on 400 to 600 millimeters and thrives in poor soils without any soil amendments. Carbohydrate content sits at 50 to 60%, with slow-digesting, resistant starches. Fat content ranges from 6 to 9%, mostly unsaturated. The mineral profile includes iron, calcium, potassium, and B vitamins. But here is what colonial agricultural officers could not ignore. Bambara fixes nitrogen. 40 to 80 kilograms per hectare are deposited directly into the soil. Farmers intercropping with millet see grain yields increase 20 to 30% without purchasing nitrogen. Drought tolerance exceeds commercial legumes substantially. Bambara tolerates 400 to 600 millimeters of annual rainfall. Peanuts require 500 to 1,000 millimeters. Soybeans require 600 to 1,200 millimeters. So here is what nobody explains. If this provides complete protein, fixes nitrogen, survives drought, and requires zero inputs, why is it not foundational to food security programs? Colonial scientists documented all of this, and they made deliberate choices. Bambara groundnut thrives where commercial legumes die. When rainfall drops below 500 millimeters, peanut fields fail. Bambara still produces. Temperature tolerance spans 25 to 35 degrees Celsius. Soil adaptability is equally striking. On poor soils, sandy soils, and degraded soils, Bambara grows without amendments. Flexibility. In the growing season fits rainfall patterns, 90 to 150 days from planting to harvest. Intercropping advantages compound. Plant with millet or sorghum, and grain yields rise. Colonial agricultural departments documented all of these advantages. British surveys from the 1920s through the 1940s noted drought tolerance, nitrogen fixation, and intercropping benefits. French agronomists in West Africa studied Bambara extensively. The data entered official records, but the classification language reveals intent. Crop of native cultivation, subsistence legume, not recommended for commercial development. They knew what Bambara could do. They documented advantages over crops they were promoting. They classified it unsuitable for the export economy they were building. Colonial departments had all this data. So why build export economies around crops requiring inputs Bambara did not need? The answer is in colonial policy, and it was never about African nutrition. Colonial administrations existed to extract resources for European industry. British and French governments required export crop quotas. Peanuts, cotton, palm oil, crops feeding European manufacturing, not African families. Peanut promotion consumed massive resources from the 1920s through the 1950s. Free seeds were distributed. Technical extension services were funded by the government. Purchasing infrastructure was built specifically for export. Rail lines to ports, processing facilities, all designed to channel African labor toward European industrial needs. Peanuts produced oil for margarine and soap. Cotton fed textile mills. The Belgian Congo provided the most brutal example. Farmers were forced to grow cotton while the colony imported food. Hunger increased while cotton bales filled ships bound for Europe. Bambara groundnut appeared in the same surveys that promoted peanuts. Extension officers documented it. Reports noted complete protein, nitrogen fixation, and drought tolerance. Then it was classified as not suitable for export development. It lacked commercial uniformity. It was a native preference crop. These were economic dismissals. Bambara had a fundamental problem from the colonial perspective. Africans ate it. They did not sell it. Villages grew Bambara for household consumption. No export taxes were collected. No shipping revenues were generated. The economic structure required export crops. The system needed Africans producing commodities for export, not growing complete protein legumes for themselves. Protein deficiency increased in regions converted to peanut monoculture. Women farmers resisted where possible. The crop persisted because African knowledge prioritized survival over compliance. Independence changed governments. It did not change agricultural priorities. The colonial export economy ended on paper in the 1960s. The institutions it created remained. The Green Revolution arrived with the same input-dependent model. Development programs focused on crops, requiring purchased packages, improved soybeans, hybrid maize, all designed around fertilizer, pesticides, and annual seed purchases. Bambara received virtually no research attention. Research investment disparities tell the story. The International Institute of Tropical Agriculture and the International Crops Research Institute for the Semi-Arid Tropics spent tens of millions developing improved soybean varieties. Bambara received minimal funding. Seed banks collected Bambara germplasm. Collection is not development. Seeds sat in storage while resources flowed to crops fitting industrial models. Soybeans received over 100 improved varieties in 50 years. Bambara received fewer than 10. Extension services embedded the bias. Agricultural officers were trained to promote commercial crops. Development aid structures reinforced neglect, including World Bank programs and USAID initiatives, all funded input-dependent crops. You cannot sell fertilizer for nitrogen-fixing crops. You cannot patent ancient land races. You cannot create dependency when farmers save seeds indefinitely. Women farmers remained primary cultivators. They understood what development agencies denied. Women kept these systems alive. Bambara groundnut represents everything industrial agriculture cannot tolerate. Every advantage valuable to farmers makes it worthless to corporations. Bambara stands in the way. Patent impossibility. Bambara is an ancient African crop in the public domain. Seed companies cannot control Bambara the way they control patented varieties. Farmers save seeds, replant, and share. No annual purchases required. Fertilizer market threat. Bambara fixes nitrogen, 40 to 80 kilograms per hectare. Companies like Yara and Mosaic generate billions selling synthetic nitrogen. A crop producing its own nitrogen eliminates that revenue. Nitrogen is the crux. Pesticide market threat. Natural pest resistance means minimal chemical applications. Pesticide sales are reduced. Equipment market threat. Bambara is hand-planted and hand-harvested. No specialized planters, no combine harvesters. Hand labor replaces heavy machinery. Development model threat. The Green Revolution framework assumes crops need technical packages. Bambara thrives without that infrastructure. Green assumptions fail. Complete protein threat. African countries import millions of tons of protein annually. Bambara produces complete protein domestically. Complete nutrition is available locally. Industrial agriculture profits from crops requiring annual inputs, seeds purchased yearly, fertilizer applied seasonally. The dependency model generates perpetual revenue. Profits drive the system. Bambara generates autonomy, self-sufficiency, and zero input abundance. Autonomy is the outcome. Monsanto, now Bayer, spent decades promoting input-dependent crops across Africa. Throughout that period, Bambara offered complete protein without requiring a single product these institutions sold. They chose corporate profits over African food sovereignty. 50 years of institutional neglect followed, while protein deficiency remained a crisis. Profits were prioritized over people. Understanding why requires understanding how development profits work. Loans tied to input purchases, fertilizer packages, improved seeds. African governments borrow money to buy products from corporations that lobbied for the development programs. Loans create the linkage. The debt creates dependency. The dependency creates markets. Debt fuels the cycle. Bambara threatens this structure. No inputs to sell means no loans to service, no debt created, and no perpetual revenue. Threat is built into the crop. Climate change exposes the absurdity. Rainfall is declining across the Sahel. Input-dependent crops are failing. Yet institutions promoting climate adaptation continue funding crops requiring irrigation and fertilizer. Bambara, surviving exactly the conditions climate change creates, remains classified as a minor crop. Climate trends make the case clear. Research emerged in the 2010s. Universities studied Bambara with limited funding. The Food and Agriculture Organization listed Bambara as neglected in the 2020s. Neglected by whom? Not by West African women farmers who never stopped growing it. Neglected by institutions that chose export crops over food sovereignty, and by development agencies that prioritized input sales over nutrition. The neglect was institutional, deliberate, and economically motivated. Cultivation persists despite official abandonment in Burkina Faso, Mali, and northern Ghana. Women farmers maintained seed networks and kept varieties alive. Bambara groundnut still grows across the Sahel. Current cultivation estimates suggest 330,000 hectares scattered across regions where women farmers refused complete abandonment. Research validation is emerging. Universities in Ghana are studying nutritional profiles. Researchers in Botswana are breeding improved varieties. Publications from 2015 through 2024 confirm what West African farmers knew for centuries: complete protein, drought tolerance, and nitrogen fixation. International interest is rising. The crop that colonial agriculture dismissed as subsistence is being rediscovered as a climate solution. Commercial products are appearing in African urban markets: Bambara flour and roasted snacks. But notice what is not happening. No major seed company investment. No government large-scale promotion. The institutional bias persists. Knowledge survives in the networks that preserved it. Women, farmers across West Africa, are still saving seeds, still planting, still harvesting. Every person who learns that this complete protein legume, once dismissed as subsistence, actually offers superior nutrition becomes harder to control. Every farmer growing Bambara without inputs proves industrial agriculture's dependency model is unnecessary. Bambara groundnut still grows. It still fixes nitrogen. It still produces complete protein. It still offers food security to anyone willing to remember what institutions spent 50 years erasing. The colonial officers knew. The development agencies definitely know. And now you know.